So guys, we talked about the standard equations of two ellipses basically. One was the one which has major axis along x-axis of length 2a and minor axis along y-axis of length 2b. Clearly a is greater than b in that scenario. Both the foci are lying on the x-axis. The equation is given by x squared by a squared plus y squared by b squared equals 1. The other one in the standard form was which one? Just the opposite of it. The major axis is lying along the y-axis and the minor axis is lying along the x-axis. Major axis is again of length 2a, minor axis is again of length 2b. A is greater than b. Both the foci are lying on the y-axis. The equation is given by x squared by b squared plus y squared by a squared equals 1. Again a is greater than b. The only difference in here is a is greater than b in the first scenario. A square is sitting as the denominator of x square and b square is sitting in the denominator of y square. In the second scenario, a is greater than b but a square is sitting below y square and b square is sitting below x square. How do you actually infer about the nature of the ellipses by just perceiving these equations? I would be discussing with you in a short while, but before that, let us talk about some terminology before we move on to the basic observations about ellipse. The first thing is talking about eccentricity. Eccentricity of an ellipse. Eccentricity of an ellipse is something denoted by small e, and what is this? It is the ratio of distance from the center to one of the foci, distance of the from the center to one of the foci upon distance from the center to one of the vertices of the ellipse. Ratio of these two things is what is called the eccentricity of the ellipse. In what context am I actually trying to make you understand this is? Let me talk about the standard equation or the standard form of ellipse. If I am taking this to be my standard form, one of the standard forms, I am taking it to be this one, right, when the major axis is actually along the x-axis and minor axis is along the y-axis. Now in this scenario we always take this distance to be 2a and we take this distance, that is the minor axis length, to be 2b. I am saying in this case this is my focus, f1, f2, these are my foci, that's my center. You know that the distance between both the foci is 2c. So what is OF1? OF1, if from f1 to f2 the distance is 2c, from O to f1 the distance is c, and I know that these are going to be my vertices. If I have taken AB's length as 2a, what is the distance from O to A? O to A, it is small a. OF1 is representing the length of the segment joining O to F1, or it is representing the distance between O and F1, or it is representing the distance from the center to one of the foci, and that is my small c. So I can now replace the numerator by small c, because numerator is representing distance from the center to one of the foci, which actually in the standard form is small c. And what is OA? OA is representing the length of the line segment joining O to A, or OA is representing the distance between O and A, fine, or I can say it is representing the distance from the center O to one of the vertices A. From the center O to one of the vertices A, distance is given by small a, so denominator will be small a. There is no problem in writing a in the denominator because I know this is the standard form whose equation is given by x square by a square plus y square by b square equals 1, where a is greater than b and 0 is less than C less than A, this implies A is greater than 0. So because A is a positive real number and therefore I can write A definitely in the denominator. Eccentricity is denoted by E. I have this as my very eccentricity of the ellipse. Is it understood? E is equal to C by A, where C is representing the distance from the center to one of the foci, A is representing the distance from the center to one of the vertices of that ellipse. So remember this, E is equal to C by A. This is the very first thing that I wanted to discuss with you. After this, the next thing is related to perceiving the equation of ellipse. I am saying consider the standard equation. Consider the standard equation of the ellipse, that is x square by a square plus y square by b square equals 1. If you consider this, you can write this. This is actually the equation of this ellipse, such an ellipse which has major axis lying along x-axis, both the foci on the x-axis, minor axis lying along y-axis, major axis has length 2a, minor axis has length 2b, a is greater than b. This equation is of such an ellipse. We have already inferred that. For this ellipse only, I am inferring something else from this equation. Now, if you are removing y square by b square, see y square is non-negative quantity, b square is non-negative quantity, in fact a positive quantity. So, y square upon b square is definitely a non-negative quantity. When you are removing a non-negative quantity from this number 1, obviously the answer is going to come out to be less than 1, because y square by b square is in itself less than 1. So when you are removing a smaller quantity than 1 from 1, obviously the final answer will be less than or equal to 1, because this can be 0 also. This implies x square by a square is less than equal to 1, which implies x square is less than equal to a square. X square is less than equal to a square. That can only happen if x is greater than equal to minus a, less than equal to a. If x is going to lie between minus a and a, then only x square will be less than equal to a square. Is it clear? You can also understand that from the graph of square function. That's the graph of the square function. Fine. Say this is minus a, say this is a. In that case, I know that actually this point is representing a square. So for x square to be less than equal to a square, that means x square can lie from here to here. For x square to be less than equal to a square, it should come from in between minus a and a. For these points, that is from minus a to a, minus a included, its square is lying between 0 and a square. Right? So for x square to be less than equal to a square, x square is always greater than equal to 0, x has to be greater than equal to minus a and less than equal to a. This means what? X is representing the x coordinate of all the points lying on this ellipse. The x coordinate of all the points lying on this ellipse are always going to be greater than equal to minus a and less than equal to a. That means what? I can say that the x coordinate of all the points lying on this ellipse is going to be between minus a and a. This point you know already, it is minus a comma 0, and this point is a comma 0. So x coordinate is going to come only from here. X coordinate is going to come only from here. Here means it is going to come from minus a to a. That means if I talk about the line x equals minus a, this is my line x equals minus a, and this is the line x equals a. This is x equals minus a and this is x equals a. I can say if the x coordinate of all the points is coming from minus a to a, minus a included, that means this entire ellipse is lying between these two lines x equals minus a and x equals a. It is between these two lines that this ellipse is packed, right? Because x coordinate is not exceeding Here an x coordinate is not exceeding here as well. That means x coordinate of all the points is lying between minus a and a. That means completely lying between x equals minus a and x equals a is my entire ellipse. So this implies the ellipse given by x square by a square plus y square by b square equals 1 lies between the lines x equals a and x equals minus a. Moreover, if you are going to not keep x square by a square here, but instead keep y square by b square over here, you will have y square by b square equals 1 minus x square by a square, which is again less than equal to 1. You would be getting y square by b square is less than equal to 1, y square is less than equal to b square. That means y is lying between minus b and b. Moreover, y also lies between minus b and b. That means the y coordinate of all the points lying on this ellipse is lying between minus b and b, minus b included. No y coordinate can ever be less than minus b lying on this ellipse, and no y coordinate can be greater than b. So in here, that means the y coordinate of the points is coming from minus b to b. This point is minus b, this point is b, isn't it? I am going to write this as 0 comma minus b, and this is 0 comma b. So the y coordinate of all the points are coming only from this range of y axis, and x coordinate of all the points is coming from only this portion of the x axis. So if y coordinate of all the points is coming only from this portion of the y axis, that means if I consider the lines, this line, what is this line? This line is y equals minus b, and I also consider this line is y equals b. You can clearly see that the entire ellipse is also lying between these two lines, y equals minus b and y equals b. So I can say moreover y is lying between minus b and b, therefore the ellipse given by x square by a square plus y square by b square equals 1 is lying between the lines y equals minus b and y equals b. So basically my entire ellipse in the standard form is packed between four lines, x equals a, x equals minus a, y equals b and y equals minus b. That means the x coordinate of all the points is only coming from minus a to a portion of the x axis, and the y coordinate of all the points is only coming from minus b to b portion of the y axis. Is it clear? After this observation, one small observation talking about symmetry if I go. See, focus on the y axis. Focus your attention on the y axis and try to understand whatever is the shape on the left hand side of the y axis, its exact mirror image, if I consider y axis as the mirror, is on the right side of the y axis. That means y axis is acting as the axis of symmetry for this ellipse. Now change your perception. Focus upon the x axis now. Focus upon the x axis. Whatever is the portion of this ellipse on the lower side of the x axis, its exact mirror image, if you consider x axis as the mirror, is lying on the above side of the x axis. That means even x axis is acting as the axis of symmetry for this ellipse. So in the context of ellipse, I can always say that both x axis and y axis are the axis of symmetry for this ellipse. Whenever we talk about ellipse, both the axes actually come out to be playing the role of axis of symmetry. So the third point is, for the ellipse, x square by a square plus y square by b square equals 1, both First question is for 2 marks. It says find the equation of the ellipse which has major axis along the x-axis and it passes through 2 points 4, 3 and -1, 4. Now equation of ellipse with major axis along x-axis and center at origin. We are talking about standard equations only. So if the major axis is along x-axis and the center is at origin, is given by x square by a square plus y square by b square equals 1. Basically the ellipse in that situation looks like what? Looks something like this, right? The major axis is along x-axis and the center is at origin. This is my origin. That's my major axis. That's my minor axis. So this is 0, b, 0, minus b. This is a, 0 and this is 0, minus a, 0. And this point is 0, 0. The equation of this is x square by a square plus y square by b square equals 1. A is clearly greater than b. Now it is given that these 2 points 4, 3 and -1, 4 are actually lying on this ellipse. X and y represent the x and y coordinates of all the points which lie on this ellipse. That means the x and y coordinates of these 2 points are going to satisfy the equation of my ellipse. 4, 3 and -1, 4 lie on the ellipse star. So its coordinates are going to satisfy the equation x square is 4 square by a square plus y square by b square equals 1, and again -1 square by a square plus 4 square by b square equals 1. Say this is 1, say this is 2. When you solve 1 and 2, solving 1 and 2, it's very easy. You can see both the equations are in 2 unknowns, a square and b square, so you can clearly solve them. You will get a square is 247 by 7 and b square is 247 by 15. Therefore, equation of ellipse turns out to be x square by a square plus y square by b square equals 1. So eventually you will be getting 7x square plus 15y square equals 247. This is the equation of the required ellipse. Next question says that find the coordinates of the foci, vertices, eccentricity, and also find the length of the latus rectum of the hyperbola y square minus 16x square equals 16. If you have y square minus 16x square equals 16, I can divide throughout by 16. You will be getting y square by 16 minus 16x square by 16, so it is x square by 1 equals 1, which resembles the standard form y square by a square minus x square by b square equals 1. So where a square is 16, b square is 1. Fine. So here we are talking about the hyperbola with foci on the y-axis. So it's something like this. Fine. So this is y square by 4 square because it is 16 minus x square by 1 square equals 1. You know that from here to here, this is my transverse axis. The endpoints of the transverse axis are my vertices. The length of the transverse axis is actually 2a. So these points are going to have what? A square is 16, that means A is 4, B is 1. So this point is 0 comma A and this is 0 comma minus A. Fine. 0 comma A, 0 comma minus A. Here is your focus. The length of your conjugate axis is 2B. Length of your conjugate axis is 2B. From here to here it is B, from here to here it is B. What is B? B square is 1 square, so B is 1. This is 1 comma 0. This is minus 1 comma 0. So if your A is 4, B is 1, I know in this hyperbola what happens is B is defined as under root C square minus A square, which is under root, or I can write this then. I don't know what is C, so I'll write B square equals C square minus A square, or C square is B square plus A square. B square is 16, A square is 1, so this is 17. So C is root 17. Basically C is nothing but, or 2C is nothing but the distance between the two foci. So from here to here it is C, here to here it is C. This point is 0 comma C, that is root 17, and this point is 0 comma minus root 17. Fine, so foci has coordinates 0 comma root 17, 0 comma minus root 17. The vertices have coordinates 0 comma 4, 0 comma minus 4. After that I talk about eccentricity. Eccentricity is given by C upon A. C is coming out to be root 17. A is 4. So this is my eccentricity. Length of latus rectum. If I talk about latus rectum, this is my latus rectum. This, both the latus rectum have exactly the same length. Length of the latus rectum. Length of latus rectum is 2B square by A, that is 2 into B square is 1, A is 4, so this gives you 1 by 2. So now let's get back. Coordinates of the foci are 0 comma plus minus root 17, because the focus is lying along the y-axis. Vertices have coordinates 0 comma plus minus 4. Vertices are also lying along the y-axis. Eccentricity is coming out to be root 17 by 4. Length of the latus rectum is coming out to be 1 by 2. Is it understood? After computation of all these values, let's move to the next question. Next question says what? Let's try to examine that. We have third question saying find the equation of the circle which passes through the origin and cuts off intercepts 3 and 4 from the positive parts of the axis respectively. So here basically the circle is doing what? The circle is passing through origin somewhat like this. The circle is moving. It is cutting off an intercept on the positive x-axis, cutting off an intercept on the positive y-axis. Now this is origin. It is cutting off an intercept of 3 units on the positive x-axis. This point is 3 comma 0. It is cutting off an intercept of 4 units on the y-axis. So this point is 0 comma 4. I need to find the equation of this circle. This is my center. Say the center has coordinates h comma k. Let the equation of the circle be x minus h whole square plus y minus k whole square equals r square, where this distance is r, that is the radius. Now if this is r, drop a perpendicular here and talk about this triangle. Say this point is P, this is point is O, and say this point is R. In triangle, right angle triangle POR, what are you getting? Obviously if this complete is 3, OR is half of 3, and if this complete is 4, if I talk about dropping a perpendicular from here to here, say this is S, then PS is half of 4 and PS is same as PR, right. So, you are getting PR is 2 and OR is 3 by 2. In this right angle triangle, then you can compute OS. You know that hypotenuse square is equals to base square plus perpendicular square. OR is 3 by 2 square plus PR square, PR is 2. This is 9 by 4 plus 4, this is 4 into 4 is 16. 16 plus 9 is 25 by 4. So, clearly OS is 5 by 2 and OS is nothing but the value of R. Now, if this is R, clearly if this is R, that means what? What do you mean by this? Now, H is what? H is this distance and K is this distance. K distance is clearly 2. What is K? K distance is clearly 2. How far is this point from the origin? This is going to give you the coordinates of the center. What will be the coordinates of my center? This complete distance, this is R and this is, what is this? This is my K. Isn't this K? Isn't this quantity K? If I have my R as 5 by 2, what is my K? What is K? K is the y coordinate of the center and this is equal to, exactly equal to 2 itself, because this itself is my quantity K. So, K is 2. If you have got your K, you have got your R, have you got the coordinates of your center or not? Is H and K both computed successfully and R computed successfully, so that you can then write the very equation of this circle by replacing H, K and R by the respective quantities? Give it a thought and we would be right back to the same question, completing it and moving to the next.